Okay, fuzzballs, we're going to try to make this real quick. All right, because I got to go home. All right, I got to go home and see a baby. He's small and he's a baby. Now, what we're going to do is we're going to talk about interpreting speed time graphs real quick because just in case we didn't cover it enough when we were doing it. Now, these lines are going to be perfectly perpendicular, despite what you may think. I have a lot of practice drawing horrible lines. Let's make this occur. Okay, there we go. There are two lines. Now, let's go ahead and see if we can't describe something as a speed time graph. Okay, so here's our speed on this axis in meters per second. Here is our, oh gosh, seconds, time in seconds. Okay, cool, neat. Okay, cool, okay, neat. Oh, okay, cool. Now, let's say that we have an object that did something like this. Let's say that it was, okay, here's our object, here it is. No, here's our object, this is our object, there's the object, okay. Let's make this completely clear. Here's our object. Let's say that the object did something like this. It went, okay. So what just happened there was we started off at rest. So on a speed time graph, we represent that by a speed of 0. So remember, this is just increasing speed on this axis. So we started off at rest. It seemed as though, in that very poorly described thing there, that our speed increased, okay, based on the sound of my voice, okay? So remember, the sound of my voice was, okay, so, wow. Okay, so as we increase our speed, there we are. Okay, we increased our speed for a moment. Then, for a very brief time, it looked like this object, whatever this thing could possibly be, stayed at a constant speed for a moment. Okay, so how would we draw that on our paper? Well, the easiest way to draw a constant speed is a speed that does not change. So it needs to stay at a certain value. So here we are, we're going to stay at this constant value. I'll try to draw it as perpendicular with the speed axis as possible. My phone just went vip vip. We'll see what that is in a second. Probably a baby. All right, so now we have just drawn a constant speed for a moment. Okay, there it is. Now, if you recall, let's go back to the other side where all this craziness happened. Okay, it went, and then it went, ah. Okay, now the ah is probably an increase in speed again. So to show that on this graph, we go ahead and we draw another increase in speed. And it was like, ah! So that probably means it was going a little bit quicker than before. So I'm going to make the slope a little larger. Even though it's hard to see that that's the case between those two lines. Now, this describes the motion of that object, once again, whatever that thing is, over that period of time, all right? So now let's think about what happened. Again, let's look at this axis. We'll travel through time, my friends, at the rate of time. Okay, so what we did was we started off at 0. As we go through time, the speed of the object increases. As we continue through time, the speed does not change. It goes at a constant rate. And then as we continue through time again, the speed increases again. Okay, so that's how you can interpret these speed versus time graphs, okay? It increases. This right here on a speed versus time graph implies some sort of acceleration. Is positive, is some positive value, okay? Then right here, this point right here, this flat space from yaw to yaw, this would be a period of an acceleration equal to, can you guess it before I say it? Equal to 0. Okay, there's no acceleration. You see that the speed does not change in this time segment. Yes, yes, the speed stays at a constant. That's what our object, once again, was doing. It went, and it stayed at a constant speed for a moment. All right, then finally, we have an acceleration again. We change our speed. We change our velocity. Acceleration is positive. Okay, now, here comes the fun part. Let's say that we wanted to go backwards. Okay, so here's our object again. Here's our object. Let's say we want to go forward and then backward. Okay? Man, so good. Okay, so, or, I don't know. Let's say they're constant speeds the whole time. So, okay, how would you represent that on a graph? Well, I suppose we can write that on this side of this paper. Gotta get my straight edge here. Is this the right one? Yeah. Okay, so let's draw our junk again. That's gross. There's that. There's that. Here's our speed. Here's our time. Everything seems so familiar. Capital T. See, look how capital it is. Capital! Okay, now, this object, it was going at a constant speed and it was going to the right. That means it had a constant positive speed. How do we represent that on a graph? We go up into the positive realm of speed and we draw a constant speed. Okay, so that means it should be a flat line. So why don't we make a little flat line here? Now, this particular scenario is impossible. You cannot do this if you recall. Well, you'll know soon in calculus that you cannot go from a positive number to a negative number here without some sort of acceleration in between. But what we're going to do is we're going to make a step graph, okay? So right there, we go at a constant positive speed. That's what the object did. Once again, who is it? We go constant positive, and then we went constant negative. So that means that if we were to represent that on this graph, we should extend our speed this way. So now we've got negative speeds down there. And it seemed like they were about the same size. Oh, I don't know, about the same size-ish. So let's measure this. It's about 5.5. So about 5.5 below should be where we start this. About yeah. So right about there. Let's see if that's right. Man, so great. Now we have a constant negative speed. So a constant negative speed looks like addition. Okay, cool. So constant positive speed. So there's no acceleration here. So constant positive speed. This is a constant negative speed. Okay, and once again, acceleration equals 0 during both of these segments. Now, if you wanted to make this a continuous graph, you would have to make an acceleration happen in between. So in real life, this object would have gone like this. It would have had to slow and then accelerate back in the opposite direction. Okay, so that would look like a steep line, a slanted line. It cannot be straight down. That is illegal. Because once again, you cannot just very quickly change your speed. You can't just change it from this to this. It's impossible. So anyway, so you'd have a constant acceleration during that time. So the speed would go from it being a positive number, it would quickly go to 0, and then it would quickly go down to a negative number. So once again, let's think about our object doing that. It's going constant, it slows to a stop, it reverses and goes negative. Okay, and that's what happens here. Constant positive, 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 slows to a stop. This is speed equals 0, right? There's our axis. Speed equals 0, then it goes down to a negative number. Okay, so once again, brief 8-minute, oh golly, sorry about that. But yeah, you get the idea. So interpreting graphs, hopefully that helps a little bit so you can see what's happening on a speed versus time graph. Enjoy, boys. I was going to say boys and girls because there aren't any girls ever. Okay, bye.